Next, we're going to discuss the topic of fermentation, which is what happens when there is no oxygen present for cells to undergo cellular respiration. As you know, cellular respiration consists of four major stages. First, glycolysis. Second, pyruvate oxidation. Third, the citric acid cycle, or the Krebs cycle. And fourth, oxidative phosphorylation, which I broke down into the electron transport chain and ATP synthesis. Steps 1 through 3 break down glucose, which is a 6-carbon molecule shown here, to produce small amounts of ATP, as well as transporting electrons to the electron transport chain via the reduction of NAD plus to NADH through the addition of an electron. NADH will then lose that electron. Here's NADH. It will lose that electron to oxygen, the final electron acceptor, and return as NAD plus to start the process again. However, if no oxygen is present, NADH cannot be oxidized in the electron transport chain, and cells cannot move past glycolysis or continue the cycle. This would result in cell death. However, cells have developed a process to continue producing small amounts of ATP through substrate level phosphorylation when oxygen is not available, through the addition of 1 or 2 NADH regeneration steps. This is what we refer to as fermentation. When we take away that electron. There are two types of fermentation that we'll discuss. They ultimately differ in which molecule is used as an electron receptor, allowing NAD plus to be regenerated. The first is lactic acid fermentation. In this process, NADH transfers its electron directly to pyruvate, generating lactate as a byproduct. So let me show you how this works. We start with glucose. We bring in 2-ADP, which is released as 2-ATP. In addition, we bring in 2-NAD plus, which is reduced to 2-NADH. Now, normally this NADH would head on over to the electron transport chain to be oxidized by oxygen and then continue this cycle. However, because there is no oxygen present, that cannot happen. So we've got pyruvate, and pyruvate can act as that electron acceptor. Pyruvate is a 3-carbon molecule. It looks like this. And it is ready to accept that hydrogen. And once it does, this hydrogen here, once it does, it will become lactate, which looks like this. Now this hydrogen here, that is the hydrogen that we got from the NADH over here. So this hydrogen here attaches there, and then we get to return the 2-NAD plus to continue this cycle. Muscle cells are an example of a type of cell that carry out lactic acid fermentation. They do this when there is not enough oxygen present for aerobic respiration, like if you've been working out very hard. Another example of cells that use this are certain bacteria and fungi used in the dairy industry to make cheese and yogurt. The other type of fermentation that we'll discuss is alcohol or ethanol fermentation. In this process, the NADH donates its electrons to a derivative of pyruvate, which is called acetaldehyde. This requires an additional step and eventually produces ethanol and carbon dioxide. So let's talk about how this works. Once again, glucose is broken down into pyruvate through the addition of those 2-NAD plus, giving us 2-NADH. We've got our pyruvate. which then needs to be broken down into acetaldehyde and carbon dioxide. So this is our acetaldehyde. Acetaldehyde can then accept this hydrogen right onto here, becoming ethanol, which looks like this. This gives us NAD plus again. We can go back and continue the cycle. Yeast are an example of a cell type that uses this process to produce ethanol and CO2. We use yeast in brewing, winemaking, and in baking. The CO2 produced is what allows bread to rise. Now, as a note, fermentation is not the same as anaerobic respiration. Some organisms are able to complete all 4 steps of cellular respiration without the presence of oxygen by using an alternative form of an electron receptor, such as the sulfate ion, which is SO2 -4. This could also accept those electrons, and this allows for large amounts of ATP to be produced. Both aerobic and anaerobic cellular respiration result in up to 16 times the 2 ATP that is formed through fermentation. So we're going to get about 32 ATP through anaerobic or aerobic respiration. That's when following all of the 4 steps of cellular respiration, versus only 2 ATP from fermentation. Some organisms, such as yeast and some bacteria, can survive on the small amounts of ATP that are produced through fermentation. In fact, many of these organisms, cannot survive in the presence of oxygen and are therefore referred to as obligate anaerobes. They don't have a choice but to survive this way. They can't survive with oxygen. Those organisms that are able to switch back and forth between cellular respiration and fermentation are referred to as facultative anaerobes, and they only use fermentation when they're unable to undergo cellular respiration.